Page 421, lesson 8.2 is on drawing geometric figures. Basically what's going to happen in this lesson, they're going to give us some information and we're going to draw the figure that they ask us to draw. So if you look at this solve and discuss it, we have some students that are designing a flag with the school's mascot and emblem. And so the flag has 4 sides. 2 sides are twice as long as the other 2 sides. So what shape could the flag be and what dimensions could it have? We're going to mainly just focus on what shape it is. Obviously, to answer the question fully, we would have to give dimensions as well. But if we just focus on, so it's 4 sides, 2 sides are twice as long as the other 2 sides. So one thing that could work for that, which you might naturally think of for a flag, would be a rectangle. So a rectangle, if these are both twice as long as these, okay? And we could come up with dimensions, you know, let's say this is 6 feet and this is 3 feet, for example, whatever. Okay, so that would be one option. Another option, I don't know if I've seen a flag that's got this shape before, but you could technically have a kite. Okay, something like that. You could use the same dimensions if you want. And then we have one other option that we could make with the information, what they're telling us here. And that final option would be a parallelogram. Parallelogram, something like this, okay? So those would be our 3 options that we could do on this problem. So we'll look at example 1. The school's landscaping club is designing a 4-sided patio and garden. The patio has 2 perpendicular sides that each measure 4 yards. A 3rd side that's perpendicular to one of the equal sides but twice as long. And then one angle of the patio measures 135 degrees. Make a scale drawing using a scale 1 centimeter equals 1 yard. Okay, so we could do this with our rulers. We would be using the centimeter side. One thing before we get going on this would be that we need to make sure we know what perpendicular means. So I think we've talked about that before, but perpendicular means that they meet at a right angle. Okay, 2 things meet at a right angle, it's called perpendicular. So, for example, those 2 line segments are perpendicular to each other. So if we look at what they did in your book here, this is worked out. The first thing would be to draw these sides. So 2 sides that are perpendicular, they're 4 yards, which we're going to make as 4 centimeters, and they meet at a right angle. So that would be the first thing I would do, is we could put this 4 centimeter side here, this 4 centimeter side here, and then they have to meet at a right angle. So there's the 90-degree angle. And then it says the other side, another side meets one of those at a right angle, and it's twice as long. So that would be 8 centimeters on our drawing. Okay, and then at that point, that's the end of what the book's calling step 1. And then for step 2, they are saying that we can use a protractor to draw that 135-degree angle. You can do that to check it, but you really don't have to use a protractor, because at this point we have our lines drawn. So this segment at the bottom has a definite endpoint. This segment at the top has a definite endpoint. So we could just draw a line connecting those two, and we should have our 135-degree angle as it is. Okay, so you can double check that you've got the right measure, but it's really just connecting those 2 points. There's only one way we can connect those two to each other, is by drawing a straight line. So really, I would argue we don't even need the protractor technically, other than just to double check we did it correctly. Okay, and then that would be, you can see that would be a trapezoid, because the top and the bottom sides are parallel to each other. These little symbols like this, these little triangles, sometimes they do like 2 triangles. You'll learn more about that in high school, but that's the symbol they use sometimes to show that sides are parallel to each other. So if we look at the try it, they want us to use a ruler and protractor to draw a quadrilateral with 2 equal sides that meet at a right angle. And 2 non-adjacent angles of the same measure. All right, so before we do this, we need to talk about non-adjacent angles. We'll get a definition for non-adjacent. Non-adjacent angles are basically angles that aren't next to each other. And we talked about adjacent angles of like 2 angles that share a common ray of being adjacent. Actually, we can have with even quadrilaterals and things, we can talk about adjacent and non-adjacent angles. So let's say, for example, in this picture, I've got this trapezoid. Okay, obviously these are different angle measures than each other in this one, but angle 1 and angle 3 here are non-adjacent angles. How do I know they're non-adjacent? Well, because we skipped an angle in between them. Okay, so since we had one angle, we skipped an angle, and then we had the other angle, that makes them non-adjacent angles. So if we go back to our problem, we have 2 equal sides that meet at a right angle. So we'll try to do that here. Okay, so these are meeting at a right angle. And those are about the same length here. Okay, it's maybe not perfect, but it's pretty close. And I've kind of cornered myself in here a little bit. I probably should have given myself more space up here. So I don't know if this is going to be distracting or not, but if you can ignore that, I'll try and make my other sides maybe with a different color. So there's not just one answer that's going to work for this problem. There's multiple answers that we could have. If you think about this, in a quadrilateral, something that's got four sides, it's got four angles. The angles add up to 360 degrees. Like, for example, in a square, you have four 90-degree angles. Four 90s makes 360. So if we tried something, so we were going through this, and the suggestion was made, what if we make those other two angles equal to 45 degrees? So if we have 90 and two 45-degree angles, that's 180. We've got 360 total. That would make our other angle 180 degrees, which would make this be a straight line, which basically just means we would be making a triangle, not a quadrilateral. So that tells me that I'm going to have to pick something bigger than 45 degrees. So we're going to try 50 degrees here and see what happens. Kind of boxed myself in a little bit, so I'm going to try to use a different color for the second part here. Okay, and I'm not quite at the end there of that line. So if that's 50 degrees, and I'm having a hard time with my protractor stuff here on my program that I've got. Okay, so I'm not getting that to quite work out right somehow. I think it probably could work, but let's maybe we'll try an obtuse angle instead. See if that works out any better. So we're going to try a 100-degree angle. See if we can get this to work here. And I know you can't see it, but I've got a ruler here it's allowing me to change my angle measurement. I'm having a hard time here. So if that's 90, we just want 10 more degrees from that. Okay, so that would be about 100 degrees there. We'll do the same thing over here. We'll talk in a minute. I'll talk to you about how we could do this using your protractors. Okay, so that should be about 100 degrees there also. And you can see then what we've created here. Basically this, the one part here on the end, this part on the end, we would take that off. We would just erase that. So you can see then that would be a kite. And like I said, there are other ways of doing this. Basically on your protractor, what's going to happen is you're going to have a, depending which kind of protractor you've got. So if you have one of these protractors, you're going to be looking at, there's this triangle at the bottom right here. If you were going to make an angle measure, what you would want to do is you would want to line that up, and you're not going to be able to see it there very well, but you would want to line that up with the end of your line segment. So let's just use blue. So if this was my line segment down here, I would be lining that triangle where that meets, where that triangle points down. I would be lining that up with the edge of that line. And then if I was doing a 100-degree angle, there's technically two 100ths on this protractor. So there's 100 over here, and there's 100 over here. What I have to think about is 100 degrees is an obtuse angle. So the deal is, you might think, well, why don't they just have one number? Well, it depends on which way you're going. If you're coming from the left or from the right. So we just have to think about, we know 100 degrees is an obtuse angle. It's more than 90 degrees. So if I try over here and connect that, that's actually going to be less than 90 degrees. That's going to be an acute angle. So that tells me I would need to use this measure over here. And then what you can do is just put a little mark right above the 100. And then if you just connect that line, then that gives you your 100-degree angle. And for this one, you would be coming from a different spot. So you'd be actually, coming from over here to measure that 100-degree angle. And then you'd be also over here to measure your other 100-degree angle. So look at example 2. Mr. Miller's classroom has desks shaped like equilateral triangles. He's planning to arrange the desks for a lunch for 10 people. If one person can sit at each edge of each desk, make a sketch to show how many desks he needs. So one way of doing this, we just have one person sitting on each edge. We could go kind of alternating the desks, and then you can see the circles on the outside here represent the people. So there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And that's by using 8 desks. So 8 desks for that arrangement. That would be kind of a longer lunch table. Another way of doing this is a little bit wider lunch table. A little bit wider going this direction. In this one, if you look at it, technically we have really nobody sitting at any of these desks. So, I mean, if you didn't have that many desks, you wouldn't have to have those, but if you had those used, that would be 14. Otherwise, if you didn't put anything here and just had spaces there, empty spaces, you could actually make that arrangement using 10 desks. Okay. There's other ways of arranging this as well. If we look at going down to the triad at the bottom of the page. So skipping over example 3 for a minute. If you look at this, they're just talking about other ways we can arrange the desks. So one way would be we could just separate the desks from each other. If you separate these from each other, you could get 3 people on each side. And then maybe we'll not have somebody sit by themselves. We'll move somebody over there maybe. Anyway, you could get, with 4 desks, you could actually make that work with 10 people. Another option would be just kind of putting the desks in a circle, like this, or however that comes out, whether it's a circle or not, I don't know, but you could do that with that's 6, so 7, 8, 9, 10, if it works. Sometimes theoretically things seem like they should work and then actually they don't. And then another thing we could do would be we could make something like this. You could actually get 5 people around that, and then if you do one more of those, that would give you another 5. So you could get that with 6 desks. So lots of different arrangements that we could do. So we'll continue this lesson later. Have a good day.